Hello, N3FJZ here. And this is a quick start guide for my MAX-SSB front panel for the MEGA microcontroller. Okay, upon first power up, the unit will realize that there are no settings in the EEPROM and will set factory defaults. And you will need to set up your unit for whatever specific conditions you have for how you bit your RF deck, and there's other settings that you'll need to set. So the first thing you'll do is hit the well, here I'll show you the push button. Since I'm going to be showing the display, you should have built your unit with the following buttons. You'll have your left and right, up and down, the home save, then you'll have menu select, and there'll be 4 function keys. All right, in addition to those, you'll have your main tuning encoder, and then you'll have if you built it with a second encoder, this is called the scroll, and essentially it's a redundant feature to the up and down buttons. They'll both do the same function. Of course, on my build, I have a reset button here and a local push-to-talk switch. But in your build, you'll probably have your push-to-talk switch with your microphone. Okay, upon first power up, it will set defaults. And for you to use the unit, you'll have to go ahead and set the various functions. So you press the menu, and then the up and down buttons will select the sub-menu. And let's go through how I set mine up. Okay, hit the select button once you've selected what you want to the menu item. And here we'll be setting up the clock and time zone. Here you'll use the tuning wheel or encoder to set your DST, your time zone offset, and whether you want the local time displayed in 24-hour format or 12. As you change the different parameters, you'll see an asterisk in the field that's indicating that there's a change has been made from the default or from the currently saved settings. And what you're going to want to do is hit the F3 button, and it will tell you that it's saving the parameters. Now these are saved, and you'll see your asterisk is now gone. Okay, so that sets up the clock. You hit the F1 key for back, and of course the 3 legends here, the soft keys, to be F1, F2, F3, and F4 keys. Okay, using the down button, here we could set the IF frequency and the drive. So you hit down, select it, and then hit the select key. And here's where you would actually dial in your IF frequency. In my case, it is 9 megahertz, but of course you could set it to whatever frequency your SSB crystal filter is, and it will go down to 1 hertz increments. In my case, it's 9. And you can hit the down arrow key to select the drives. The default to full power. This is the drive level from the output of the SI5351 phase lock loop board. Here you will set your drive level. If you're not sure, you leave it on 8. And later on, as you're actually listening to the receiver, you can change these settings. And you'll hear the difference immediately as you change them. And of course, then when you made your selection, you'll hit the F3 key for save, and those parameters will be saved. Then we hit our back. Okay, you have display and beeper. Here you can set the display brightness. This particular display doesn't support contrast, so in this particular build of the firmware, it's shown, but it's not functional. And here you have, if you wired in your beeper, you can turn the beeper on and off by using the dial adjust encoder. And once you've made those changes, you can hit save. This works for all the menus, all the different selections. If you've dialed something in and you're not quite happy with what the settings were, if you hit cancel, it'll go back to whatever the saved parameter is. Also, if you make a change and you try to go back, it'll remind you that you have unsaved changes, in which case you'll have to hit the select to clear the reminder, and then if you hit save, it will save those settings. In my case, I want to keep my display at full brightness, change it, and save it. Okay. Set passcode and lock enable is not supported at this time. Temperature and unit of measure, or the temperature unit of measure. This would be for your final transistor temperatures, how you want them displayed. Here, it's the unit of measure is Fahrenheit or centigrade or Celsius. You can change it here. I also have, by hitting the down arrow key, you'll go to your number of samples that are averaged together for your temperature. Of course, the more samples you take, the more stable the temperature reading is, but it takes longer to see changes. And if you set it to a lower number of samples, you'll have a quick response, but the temperatures may be bouncing around. I found that the 25, which is the default, that works very well. If you made a change, of course, you'll hit your save. In this case, I didn't change anything. It will just say nothing to save. We hit our back, F1 key, and I believe for this particular submenu that covers that. If you then hit your select key while the back is highlighted, you go down to, you can now select alarms and lockouts. Should be the next thing you set. Highlight that with your down arrow key, hit select, and here you have several selections. PA transistor temperatures. Here you'll set your limit. If you're transmitting and your finals reach this temperature threshold, whatever you have it set for, it will then cut the transmitter out. You also have three other options. If you have the shutdown on TX alarm, this will actually turn the transmitter off on the alarm condition. If you want to pop up the display on your screen, here's where you would select that option. And if you have your beeper wired into your unit, it will beep as well. So you can mix and match these settings whatever way you'd like. Also, there is a setting the beep sound also has a master beep in another screen, so they both have to be on. So the beeper must be also enabled for you to hear this. Even though it's set yes here, you may need to change the setting on the other screen. Very similar to the transistor lockouts, you have the SWR. Here you highlight it, hit the select button. Here's you can set your SWR limit. The transmitter will turn off if it exceeds the limit. You can set 1 to 1 point, whatever this is, 2 to 1, and so on and so forth. And the same 3 conditions. You can have the transmitter shut down, yes or no, a pop-up, or even sounding a beep alarm. Currently, the battery voltage alarm is not supported. And this one's important because if it's not set properly, you'll get some unexpected results when you try to transmit if it's not set up. This here is sort of it keeps you from transmitting on a band that's not authorized for what class license you have it set for. From the default, there's no limit, so you can transmit on any frequency. You can highlight this and set to your class of license if you wanted to prevent you from transmitting on out of band. And all the way down to completely locking out the transmitter regardless. And this is, for instance, if you have it set for general, it will look at the dial display. Is a general allowed to transmit on this frequency? It will let you do it. If not, it will come up with a pop-up. Same 3 indicators. The condition will either have it will shut down the transmitter, pop-up alarm, or beep. Now, since this unit was developed primarily for single sideband, this is for your phone. So if you're going to do CW, this is going to interfere with you transmitting on frequencies that are in the CW portion of whatever band you have. In that case, what you're going to want to do is just put no TX limit if you're going to do CW. Okay, I'll just set it for general just to give us something to look at on the main screen. Once you've done that, you're going to hit the F3 key to save those settings. And then we're going to hit the F1 key to take us back. So that pretty much covers those settings. If we hit the select key with it on back, we also have info diagnostics. And here's where you would select your About screen. You can see what version software you're running. In this case, I have it set for, the way I do my versioning is I have the year, month, and day, and the hour that it was released. In this case, I have it, this is test, but it will probably say beta or production. And the date is redundant. I just put here a little note to myself that I made this release just for this demonstration, and it will tell you what the target platform is in this case. So yours will, depending on what version you download, you'll see that might be a little different. And when we select the select key, which is basically the OK, you'll drop out. Okay, temperature display. It just gives you the temperature to finals, and counts A and B are the internal averaging that's going on. Now, this is my fault. I didn't have a back, so if you have to hit the home button, take you back to the normal or the main display, then we'll have to go back through again. Okay, that was the info and diagnostics. There are no diagnostics at this time. Frequency counter is not supported, and it just dropped us back. Clock and geo is not supported. Frequency counter is not supported directly. And the GUI template test is something it's one of the screens I was using for development work. It doesn't really do anything other than just exercising the different functions of my software when I was developing the GUI. Okay, and probably the most interesting feature that I wrote into this, which was you don't see this in a lot of the other front panel software that I've found on the web, is the calibration is supported right from the front panel. So for the SI5351, you will have to calibrate its main oscillator, or your dial will not be accurate. In my case, with this front panel containing a GPS receiver which supports a 1 pulse per second output from the GPS system, which I've read and been told that it's pretty accurate. So you're going to get essentially atomic clock accuracy on your frequency counter display on this unit. So with that connected and you've got a good satellite fix, if you go into your calibration, select main oscillator, you'll come up with this display. Now this is from the factory. It defaults to the trim of 0. The clock drive is set to 8. That is the clock channel number 1 on the SI5351. And this is what is based on the schematic, connects that back to the frequency counter chip on the board. Okay, and then of course the top line is your 10 megahertz reference. And if your GPS is locked and you're getting that 1 pulse per second, you'll see that gate display flash. Here, it's telling us that with the SI5351 set to what it thinks it's generating 10 megahertz, it's actually generating 10 megahertz in 62 cycles. So what you want to do is highlight the trim, oscillator trim field, and as you turn the tuning dial, you'll change your trim factor. And if you turn it, if the rule of thumb here is if you look at your display, if you're high, in this case we are by 48 cycles at the moment, you would turn your frequency select dial counterclockwise. It's intuitive. You would feel that you would want to go down. So you want to keep turning this until you get a reading of 10, and as you get close, you can then drop to single digit adjustment and just dial in where you're getting a consistent 10. In the case of a digital display, you probably want to adjust it to where you're getting exactly 10 megahertz, and then occasionally it may drop down to all 9s. That's right at the edge between those two, and that's probably the exactly 10 megahertz. And once you get the setting you like, you'll hit save, the F3 key, which will save that. Now, if you're concerned about the crosstalk between the 3 channels of the SI5351, once you've set up your calibration, you can go ahead and turn off the 10 megahertz output of the SI5351. Set that clock drive to 0 for clock 1, and that will extinguish that output from that SI5351. Of course, you're going to lose your display. Your reference is gone, so it's going to display 0. And here we turn it back on again. It won't affect the accuracy if you turn it to 0. Right, once you've done that, you can hit save, And now all your settings are saved, and you've got your unit set up for normal operation. Now I'm going to hit the home key, takes you right back to the main display. And here's where you'll use your left and right arrow keys to select the dial frequency change. And if you hit the home key while you're on the dial tuning, the main screen, it will take you back to the 1K change, or the digit for 1000 hertz. Now if you double click the home, it will zero out the hundreds, the tens and ones cycles per second. It will default to 0. Okay. You have your receive and transmit indicators. Here you have your local time as you set it in your initial setup with your offset, the time zone offset. In my case, it was -5 hours. I have it set for daylight savings time. I have mine set for 12-hour format, but if you have 24, it will come up as 2400 hours in a 2400-hour format. And down here you have the UTC time and the number of seconds. Also on the display you have your lower sideband and upper sideband display indicator. And then to the right of that is your injection mode. High inject mode or low inject mode. And as you can see here, this is useful. Some combinations of IF frequency versus the dial frequency, you may end up with birdies. You even have conditions that you can't receive on. For instance, if you try to receive 9 megahertz with a 9 megahertz IF, it gets kind of it's not very good because your VFO is a very low frequency. You're right on the IF frequency there. Here in this case, you would hit your high inject mode, and you'll see that the VFO now jumps up to 17. And when you hit your high inject and low inject modes, your VFO and the BFO are instantaneously calculated, real time. I built this essentially for experimentation purposes to help me understand how to build radios and theoretically how the theory works. And as you flip high and low injection mode, you'll see the VFO and BFO frequencies change, and you'll actually hear the difference through the speaker. Okay. On the left you have your power amplifier final transistor temperatures displayed. And of course the unit of measure is changeable in your settings screen. And here you have your DC input voltage, or essentially the battery voltage of if you use this portable. And here we have an S meter based on the audio. It's an audio derived S meter. So as far as accuracy is concerned, it's probably a bit off, but it does give you a relative indication of the signal strength that you're hearing. Up here you have what class of license you have your transmit lockout set to. And this display down here will tell you what class of license is valid for the frequency you're displaying for phone. So in this particular case, 7200 General, Advanced, and Extra have the privileges where Technician and Novice does not. And here, again, as I demonstrated, my apologies that I don't support the CW and digital portions of the band. Here it just grays out the class of license, even though technically you could use it for the various classes of license. Here again, this is just for phone. I essentially developed this software just for me. And I'll probably be doing some extra work there. And of course, if you go completely out of band, even if you have it set for a license class, here in the case 7400 is not supported by any of those. Now, if you hit your F4 key, it will switch this sub-display between displaying the VFO, BFO, and IF frequencies. It will then default into Informational Mode. This is not completely fully developed, but I try to include some things here just as a proof of concept. And there's several. For instance, if you're outside the amateur band, we'll just say general coverage. And if you go to, say, WWV, it will tell you that. Here we have 2.5 megahertz. And the Canadian CHU, it will just identify. Its functionality is limited. Like again, it was just a matter of seeing if I could do it. Ideally, they're probably to make this more functional. Maybe there in the future I could have a menu item where you would select the service and it will tune the frequency. Right now, you tune the frequency, will tell you what service this is. Also, I have other things set here. For instance, if you have a background in citizen band radio, I can find one of the frequencies here. It will tell you what channel. It will say 11 meter band, channel 14, 13, 12, so forth. Well, at one point I was involved in CB back in the early 70s, around 72, 73, before it became the band that it is today. Got my start there. That's how I was introduced to amateur radio. But just for fun, I included the selection, the frequency display here. And it should cover up to, channel 40. And when you're done with that, you hit your F4 key. You'll default back to the VFO, BFO display. Okay, if you build the Stockton bridge, the forward power, reverse, reflected power in SWR is supported. So if you hit the F1 key, you go into a tune screen. Here it'll display the number of watts up to 50, the reflected power, and the calculated SWR. And when you press your transmit, your TX will illuminate. It will tell you that you're in tune mode. It will indicate the frequency that you have set, forward, reflected, and SWR, and it's also selected on the bar graph. All right, on the left here, there's a tiny mini graph that helps you fine-tune this in. So as you get down to 0, then this graph, this bar here will then show you the fractional components. I currently don't have my PA wired into my deck, so I can't demonstrate this actually working, but I believe on my YouTube channel I do demonstrate using this feature. And I think that covers the basic quick guide setup, and I covered all the features that I hope I didn't miss any. I don't think I did. Also, this will technically support a maximum frequency of 99.9999 megahertz is your highest frequency, and then of course the VFO and BFO is mathematically correct. Now, your RF deck in your SI5351 or whatever oscillator you have connected would have to be able to be capable of generating these frequencies. And it will go as low as I believe 10 kilohertz. That's the range. Now, mathematically, it would support up to 999 megahertz. I felt that was probably a little unrealistic with the SI5351 and the RF deck that you can build, but inside the source code, if you have the energy to do so, you could probably find where I have the limits set to 99, and you can take those limits off. But again, if you're going to be working with VHF and UHF, you probably won't be using my controller. You probably do something a little more sophisticated. But this is a good controller for your general HF bands between 160 meters and up. And again, your RF deck, your mixers, your IF amplifiers, crystal filter, and so forth would have to support those frequencies. Your PA would have to support that frequency as well, but mathematically the calculations do come out for VFO and BFO.
Good morning, Mike.
Oh, just waiting for everybody. ID, KG2MM at the 50. Good morning, DJ.
Good morning, sir.
Man, sounded good.
To do it, but I'm wondering if 50 volts might not be too much to put on the input side of it. Anyway, that's where my mind is this morning. KA1WW4UCK.
Okay, here I'll demonstrate the high inject and low inject change while you're listening.
Yeah, that's right. So I need to regulate the 50 volts down to 12 for the relay.
Notice the VFO and BFO frequencies. And I like this feature here because theoretically when you're studying superhet receivers or transmitters, you read about the sideband inversion, high inject, low inject. Here you actually hear it demonstrated. You shouldn't hear any difference.
And I have sent many to him. Operator error. So have a good day, Jim.
Well, thank you, Dave. Yeah, that's what I'm trying to protect against is operator error. There won't be any more Satan. No more Satan's work. We'll break with N3VS
WB9QPU, Rocco, 73 rounds.
Okay, next I'll demonstrate the SI-5351 calibration mode. Here in this case, we'll hit menu select, down arrow to calibration, hit select again, select main cal oscillators, or cal main oscillator select, and now you're dropped into the calibration. Here again, if you've turned off your drive, you'll have to turn that back on to get a display, and then you can go down to your trim. Now listen carefully. Not only do you see the reference change, you can hear the difference in the output.
Nothing heard here. K4IRY, you are up. KC1CTB after that. K4IRY, 73 rounds. Good morning to everybody on the corn cob.
Yeah, it's been fun. I hope it'll make us as much fun.
Here you hear the voice frequency change. You know you're off frequency. You can also hear the way the pass band, because you're now shifting it within your crystal filter, will change.
Good morning to you. The band is a little weak this morning. K4IRY, 73s. Good morning.
KC1CTB, you're up, and K1BCR after that. Joel, you want to put a call out and stick a 73s on it, over? Roger, roger. All copied out to all the above. Breaking with WDHAFT. This is Kilo Charlie 1, Charlie Tango Bravo here at the very tail end of our 73 round. We're looking for last minute check-ins. You're most welcome. Come on in.
This is Alpha 1 Romeo Delta A1RD from Greenville, South Carolina. I will be clear.
And that 23 foot mark, I brought it down for all the stuff that I got to do, so I just got it kind of in the neck.
Next, I'll demonstrate setting the IF frequency. This is important if you do your own crystal filter development, and say you think you built a 9 megahertz crystal filter, but actually the center frequency is something other than 9. You can then probably tune or dial it in or center it on the crystal passband, and the combination of doing that plus your high inject and low inject, you can definitely hear how it affects the signal received.
Delta 4.
Dude, the work together is going to come through this real good. That's for sure.
Okay, we're going down to settings. Set the IF frequency and drive. Also, not only is the IF frequency, you can hear the difference. You can also experiment with the drive level into your diode ring mixers or whatever mixers you're using. Here we turn the VFO to 0. There's no drive. You completely lose the audio. Here I'm changing the level of drive. I don't hear much difference, and this is another one of those learning experiences. I wanted to experiment with what does drive do with the signal received, the quality of signal received. I didn't hear anything with the diode ring mixers I'm using and the diode-based product detector. Now, if you use other topologies, maybe this will affect it. You would definitely hear the difference.
I know she's start feeling better too, getting back to normal and doing the things she wants.
Same with the BFO.
Tell you what, Dale.
That covers the drive. I just leave mine set for 4 for whatever reason other than it seems to work well. In this case, here again, if your IF crystal filter is not exactly on 9, you can experiment with the different settings. Of course, as luck has it, the There's no one speaking at the moment.
This is like a big brick, DJ, and it has to be built for the 240. It's like a box. It's pretty large. It's substantial. It has good cabling. It like 12 gauge.
Here we're changing the IF frequency. You can hear the way the passband, where it falls on the crystal filter, changes.
That number plug, the correct plug socket that goes into the back of your amp. Then about an inch after that is the box with the on-off, the little switch. Is the female socket that you take your current power cord and plug it into that. In total, this thing's about 3.5, 4 inches long.
That's what she said.
I know. It can grow, though.
Well, I did have, and I sold it, one of those power bars from MFJ, I think it was, that has it's got the switch on it, and I use it for the amps so that it's not a sudden load on it.
And of course, once you get the sweet spot, it sounds good to you, you can hit the save. In case I hit the wrong button, but the F3 key, it will say that you saved your IF frequency.
But they're dumb. The problem is I can't get to mine at the back. I can't reach over top, and I'd have to crawl underneath, which isn't convenient. So it wouldn't matter if it had the switch. It's just not.
Have it run in silent mode. You leave it. They call it 0 dB mode, but yeah, it's silent mode. The fan won't come on unless there's a high power load, a high current draw to the power supply. And then if you want to bypass that, you press the button in, and I think then the fan just runs at low time, I believe.
Oh, good. Okay. Yeah, just curious. I'm just I don't know. I was just wondering about that on-off switch, but no.
Okay. Next, I'll demonstrate the transmitter lockout function based on license class. In this case, the license class I have set is general, and down here these icons here will tell you which class of license has the privilege for this particular frequency for phone. So in this case, general is allowed, but as we go down in frequency, you'd see advanced and extra. Class licenses are needed for this particular frequency. And as you go around different further, I'm not sure where the break off is, I believe. In this case, both the advanced and extra. And here we're getting down to the CW and digital portions, which this particular feature doesn't support those on the phone. In a case, if you're transmitting on phone or digital and you want to transmit, you would just turn the license class to no TX limit. In this case, if I try to transmit, I'll get the alarm pop-up. The transmitter would have been disabled, and if you have your beeper wired into your audio, you'd hear a beep in that particular case. And even if you're on advanced or extra part of the band, you still get the alarm because you're general. But you get into the general portion, you can then transmit. And when you transmit, you'll see it flip over to the forward power, reflected power on the right-hand side, and SWR down at the bottom. You'll get a watts bar graph. Now, while you're in transmit mode, if you hit the F4 key, you'll get different sub-displays. This was another exploration that I have not completely finished development on. This little indicator here that's blinking just is saying that the front panel is receiving serial data from the GPS as far as the sentences are concerned, and that's what's that it's decoding. That's where it's getting the time. And if you see this blinking, you know that your GPS module is outputting data. Now, if you have a situation where the time is all dashes, but this is still flashing, it's just saying that the GPS module is communicating with the front panel, but it does not yet have time information. In that particular case, it may be an indication that your antenna is not positioned properly, or you need an external antenna, or there's something going on with the reception in your area for satellites. Now, I've disconnected my external GPS antenna. I believe eventually that time should drop out. Okay, and here now you see that the time is dashes, but you're still getting the indicator. That means that your GPS module is communicating with the front panel, but it doesn't have any data. It's not hearing the satellites. And of course, your 1 pulse per second in your calibration mode would not be functioning either in this case. Let me reconnect my antenna here for the GPS. Eventually the time should come back. Okay, here your time has returned. And if you've wired your panel the same right there